Now that we've thought a little bit about location, the fundamentals of location, X, Y, lats, and longs, it's a good time to reflect above us and think about the Global Positioning System, GPS, the system of satellites which provides us our location. Quick animation here of what essentially the GPS constellation of satellites looks like. Got a lovely retro drawing of the satellites in the top right as well. Essentially, the GPS network is a constellation of satellites that are always orbiting the planet. They provide a radio signal, which, if you have a device that can listen to that signal, you're in business for location data. One of the things you'll note on this animation is that at certain times, at certain places, at certain points of the orbit of the constellation, you see more or less satellites. And the more satellites that you see, the better your signal, the more accurate your location. Reasonable accuracy being the key line here as we go. So how does this work? Imagine, if you will, that the GPS satellites are sending out a bubble or a three-dimensional sphere of information out from each of them. Each of these GPS satellites has its own code, its own means of communication. And then you, with your GPS receiver of some kind, do a calculation using time and speed of light and atmospheric reflections and all that good stuff to calculate your real-time distance from the satellite. If you know your distance from one satellite or two satellite or three satellite, all of a sudden you can start doing three-dimensional triangulation. Those triangulations then allow you to calculate, well, not you, your receiver. It'd be really hard to calculate that like by yourself. Allow you to calculate where you are based on the radio waves, based on the distance, based on all of this information. Now, these satellites are sending out a decodable pattern as they are transmitting. This pattern is then inferred by the GPS receiver to know how long it's been, what the expected time difference is, so on and so on and so on. What this allows is for the GPS receiver to receive the information and make an estimate, well, more than an estimate, make a calculation of where you are, what the accuracy is of where you are, elevation, all this other good stuff. However, GPS signals are interruptible. So not only by potential bad actors interrupting GPS signals, but also by planetary factors, clouds, storms interfere with the GPS signal. Buildings bounce the signal off in weird ways. You get interference like multipath, where you're reading the information from one satellite double. Which one's the right one? Your calculations really matter in terms of which is correct. Mountains, canyons, valleys can bounce the GPS information. What time of day it is, where you are in the satellite constellation matters. Electrical interference, solar interference, the whole GPS network can be knocked off if there's a big solar storm. All of these things influence how the GPS works. So we are receiving this information from the GPS satellites. We are interpreting it, calculating it, analyzing it with our device. which can read and listen to and understand that signal. And then eventually out pops the other end, a location, like this little location here. Most of our GPS devices can get us accuracy to about 5 meters, meaning that we know where we are within 5 meters of accuracy. And think of it as, instead of you are here at this XY coordinates, you are here at these XY coordinates within a 5 meter box. Now, because the Earth isn't a perfect sphere and lat longs assume a perfect sphere, there's some issue in that conversion. We'll talk a little bit about that geodesy coming up in a module or two. There's also issues with just how GPS functions in terms of a system. The GPS system has actually been around for a long time, but it was developed by the US military. And it was a private US military thing for a long time. Government made, government use. But after the tragedy with Korean Airlines Flight 007 in 1983, US leadership, President Ronald Reagan, decided that the GPS system should be available for civilian use, meaning anyone could have a GPS receiver and anyone could find their location listening to the GPS satellite network. The idea was that tragedies like Korean Airlines Flight 007, which strayed into Soviet airspace, could be avoided if everyone had access to GPS, if everyone had access to location information. But the first GPS that was made available was not, shall we say, the most authentic representation of location. It was scrambled to a very severe and a very high horizontal and vertical error. So the horizontal error, so your XY location error, was up to 60 meters when GPS premiered. And think about the difference in utility between a GPS device telling you, you are here plus or minus 3 meters versus you are here plus or minus 60 meters. Those differences are incredible. And those differences make a lot of utilities or uses impossible. Now, in May of 2000, another US president, President Bill Clinton, ceased the intentional scrambling or ordered the ceasing of intentional scrambling of the GPS satellite signals so that civilian uses could have accurate GPS signal reading. And that's where we're at with our 3 to 5 meter errors that we have with GPS today. So to recap, we have location. Location we represent in X and Y, latitudes, longitudes, and latitudes. Longitude is X, latitude is Y. We represent those spherically because we are assuming that the Earth is a sphere in these calculations. To gather that information, one technology that we use is the Global Positioning System, GPS, which is a network of satellites broadcasting some information that our GPS receivers can listen to, analyze, and calculate to give you location. Easy.